Hi, I'm Guang, 15 years old. In this lesson on the techniques and applications of definite integration, we will be taking a look at this example we have here. Alright? So, in this example, what we'll have is to find the volume bounded by the paraboloid x squared plus y squared is equal to 4z, the cylinder x squared plus y squared is equal to 8y, and the plane z is equal to 0. Alright. So you might want to try to imagine how each of these would look like first. Firstly, we take a look at the paraboloid. Now, the paraboloid, since originally you have x squared plus y squared. Now, let's say you take a look at it z value by z value. So as z increases, your 4z increases. But for z, for your same z, you're just going to have a circle in each z value. So since when z increases, and of course z increases from 0, since x and y, x squared and y squared, no matter how small they are, their smallest value is just 0. So it starts from the bottom at the origin, 0, 0, 0, and you have different multiple ring by ring, and you just keep stacking it up. Alright? So that's pretty much how the paraboloid looks like. Now, the cylinder. So for this cylinder, x squared plus y squared is equal to 8y. Of course, you would want to move the 8y to the other side, which makes that x squared plus y squared minus 8y is equal to 0. So now, we will want to use the method of completing square. But then you realize, here you have an extra 4 squared, which is 16. But you can just add that on both sides. So here, what you'll see is, if you only take a look at this function, you will have a circle of radius 4 at 0, 4. But wait, we're taking a look at 3-dimensional, right? Since this is a cylinder. So this cylinder, since you do not have a z value inside, no matter what kind of z value it is, it will always be the same circle, which forms your cylinder. So originally you have the paraboloid, and then on the y-axis, you move towards a positive y direction by 4 units, and there you have a cylinder with a radius of 4 at y is equal to 4, and there you have the cylinder. Alright, so there's a cylinder, and of course you have the plane z is equal to 0. So how will your integration turn out? So once you imagine this kind of boundary, what you will realize is the plane z is equal to 0, or it's just a plane x or y. Now the x or y plane, so would it go, the z value, would it go from the x or y plane to the cylinder, or would it go from the x or y plane to your paraboloid? Of course, it can't really just go to a cylinder since the cylinder is infinitely high. That means your z values will actually be from x or y plane, which is z is equal to 0, and it reaches the paraboloid, which here you have the function of it. X squared plus y squared is equal to 4z. Right, so that is pretty much your values for z. Now, of course, you could think of this as a triple integration, where you're going to have your small piece of volume. Alright? But here, what are you going to have? So since we could already determine the z, now z would just be from 0 to x squared plus y squared. And in fact, that is a 4z, so which means you will need x squared plus y squared divided by 4. Right, so this is what you have for z, from 0 to the paraboloid. Right, now you know that is that for z. Now you can take a look at your x and y relationships. Now x and y, would you rather look at a paraboloid the cylinder or the plane. So the plane, we can't really get anything from it. The paraboloid, we do have three variables, but we can't really get anything from it either, since it is not what determines your range for x and y. Well, if you realize, you have the cylinder, which is purely in x and y, which is the thing that determines the boundary for x and y, right? So you just have z increasing from 0 to the paraboloid within the cylinder, alright? So, of course, then we'll have to take a look at how to solve for this cylinder. Now, if you were to just look at a base area, of course, then you could have like, so in the y direction, you're going to have, you see a circle, since if you look at a base area, that will be the circle with radius of 4. So, how are we going to continue this portion? Now, of course, here you can choose either integrate with respect to x first or integrate with respect to y first. So, what if we look at integrating with respect to x first, alright? So, if you want to integrate with respect to x first, which means you will need to write this, you need to change this form into x in terms of y. Well, you are going to have x is equal to positive negative square root 4 squared minus y minus 4 squared. And to this, you can then have 8y minus y squared, or you could just leave it its original form. It depends on which form you prefer more, alright? So of course, either form you can leave it in, but we're just going to go with the first form. So now, you will need it to be from the negative direction to the, not negative direction, it is from the negative value to a positive value, since your x is increasing, alright? So, you have x is equal to negative. I'm just going to move these a bit forward. So x is equal to negative square root 4 squared minus y minus 4 squared. Well, positive value for x is square root 4 squared minus y minus 4 squared. Right, so that would be your boundary for x. Now, the boundary for y, what will you have for them? So, the values for y. Now, if you take a look at it, since you're going to have it centered at 0 and 4, now, and its radius is 4, which means you'll see that this circle actually crosses the origin, and that will be from 0 to 8. Right, so this is essentially the part that we will have to integrate. Right, now for z, it should be rather simple since you don't really have an integrand yet. So, you'll be seeing x squared plus y squared over 4 as your integrand now, since after you integrate the z, you integrate with respect to z, you're just going to have z and substitute in the values from 0 to x squared plus y squared over 4. Alright, so next, integrate with respect to x first, and then integrate with respect to y. Now in this part, what we are going to see is, so since you are going to integrate with respect to x, we can put the 1 over 4 outside and you're going to have 1 over 3x cubed plus xy square. Then substitute in the values. X is equal to negative square root 4 squared minus y minus 4 squared, and square root 4 squared minus y minus 4 squared, and then dy. Right, so afterwards you could just substitute in the values that you have. So 1 over 4 integrate y from 0 to 8. You're going to have 1 over 3. So substitute in the x value. Firstly, you're going to have square root 4 squared minus y minus 4 squared cubed. Right, so afterwards when you substitute in the negative value, since it is a power of 3, so it'll still be a negative, but since you have already a negative when you substitute in the lower boundary, which means you're going to have twice of this amount. Alright, now we can take a look at the part behind. And for the latter part, we are going to see y squared square root 4 squared minus y minus 4 squared, and then dy. But of course, since you also have a positive and a negative part, you are also going to multiply this by 2. Right, so this will be the integration that we will now have to solve. So we're going to have half, or you can also separate them into 2 separate integrations. So instead, you're going to have 1 over 6 for the first term, integrate from 0 to 8, and you're going to have 4 squared minus y minus 4 squared, then this is to the power of 3 over 2, and then dy. And for the second part, you're going to have half, integrate from 0 to 8, and you are going to see y squared square root 4 squared minus y minus 4 squared dy. Alright, so these are the 2 parts we will have. Now for each of these parts, in your first term, what you can actually do is to directly make a substitution. So what kind of a substitution are we exactly going to make? Now, since the first term, what you can do is to let y minus 4 be equal to, so since this is something squared minus something squared, or more of a constant square minus something squared, you can choose to make this either a sine or a cosine, but that will be up to you. So in front of this, we're going to have 4. So y minus 4 is equal to 4 sine theta. Now, dy will be 4 cosine theta d theta. And theta, so since you need it to be from 0 to 8, and y, when you substitute in 0, you have negative 4, and y, when you substitute 8, you have 4, which means the values of sine theta will be from negative 1 to positive 1, which is negative half pi to positive half pi. Alright, and this is what we're going to see for the first term. So that will be a new set of boundaries. While in this part, you're going to have 4 squared minus 4 squared sine squared theta. So actually, since you have 4 square for both of these, you will be able to take out 4 square for each of them and make whatever you have in front actually more of a 4 cube. But since the dy, you're going to have another 4 that comes out, it will actually be 4 to the power of 4. Right, so 4 to the power of 4 over 6, then integrate from negative half pi to half pi. Then you're going to see cosine to the power of 4 theta d theta. And then you have to add on half. So of course, in the second term, you could also make the same substitution, but all you have to do is to make a little more expansion, alright? So what exactly do I mean by that? Since you will be able to see that y would be 4 plus 4 sine theta, where you can still take out the 4. So you'll have still 4 different 4's. Integrate from negative half pi to half pi. Well, for your first term, instead it will become 1 plus sine theta and then squared. Or for your second term, it still becomes your cosine. So you'll still have cosine square theta. And here altogether, d theta. Right, so these will be the two integrations that we will have to solve. And for these integrations, some of them you might have to use varying methods. Alright, so starting with the first. Now, integrate from negative half pi to half pi, you would want to use your double angle formula. So using a double angle formula, you're going to have 1 plus cosine 2 theta squared. But when you have this, you actually need to divide your cosine square theta. For each of that, you'll have to divide by 2. And since you have to the power of 4, which means you have 2 of those divided by 2, so we just divide the 4. Alright? So you are going to have 32 over 3. So this will be for your first term. Well, in your second term, you are going to have to kind of expand the entire thing. So expanding the entire thing, what you are going to see is so for the first term, you're going to have a cosine square theta d theta. Well, for the second term, since 1 plus sine theta then squared, you are going to have an extra 2 multiplied in front. So you will be seeing sine theta cosine square theta d theta. Alright, and for the last term, which you'll have integral from negative half pi to half pi sine square theta cosine square theta d theta. Right, so after this portion, how are we going to continue? Well, of course, in the first term, once again, you can expand and try to figure out which parts you can already solve. But for your second and the last term, what you have to do is to use a double angle formula again. Alright? So, once again, taking a look at how we can use the double angle formula. In the first term, you're going to have 3 over 2 over 3. So since the first term is just 1, you're going to have theta. Then substitute in the values of negative half pi and half pi. Or for a second term, you're going to have 2 cosine to theta, where you're just going to have 32 over 3. So cosine becomes sine. So sine 2 theta, substituting the values of half pi, negative half pi to half pi. Well, for the last term of your first part, you're going to have a cosine square 2 theta, which then once again you have to use your double angle formula. And you will get 1 plus cosine 4 theta d theta. Right, so that is for the first term. Now the second term, where you are just going to use your double angle formula. So you're going to have 2 to the power of 6 integrate from negative half pi to half pi, and 1 plus cosine 2 theta then d theta. So that is for the second part. Now in the third part, you're just going to put a sign to the back, making it a negative cosine. So negative, so since behind here you have a cosine, which makes this 2 to the power of 8 over 3 cosine cube theta. Then you have to substitute in the values of negative half pi and half pi. Well, for your last term, well, there are actually 2 different ways, or even 3 different ways of separating them, since you can choose to use your double angle formula for sine, or you could choose to use your double angle formula for cosine, alright? So in this part, what you can do is make it become add on 2 to the power of 5 integrate from negative half pi to half pi sine square 2 theta d theta, which afterwards then you change that into a double angle formula for cosine. Now the first term, you're going to see 32 over 3 pi. In your second term, you're just going to have sine pi and sine negative pi, which both are 0, so you won't have that second term. While in the third term, you're going to have add on 16 over 3 pi, since what we can already tell from the first term, when you have a theta and the boundary is from half pi to negative half pi, it just becomes multiplied by pi to get 16 over 3 pi. Now, for the term behind, since this is a cosine 4 theta, it becomes a sine 4 theta. Now sine 4 theta, when you multiply by half pi or negative half pi, that will just become 2 pi and negative 2 pi, which makes the sign 0. So that's one we also won't have. Now on with the fourth term, which you are going to see 2 to the power of 6 pi. Or if you already know what 2 to the power of 6 is, you could already just leave it in its value, which is 64 pi. So once again, you'll see a cosine 2 theta. And from what we have done previously, a cosine 2 theta will just become sine 2 theta, which will give sine pi and sine negative pi, which are both 0. So that part we also won't have. Now, cosine cube theta, when you substitute in half pi and negative half pi, both of them are 0, so that term is also a 0. Now, all that we are left with would be sine square 2 theta. Right, so we are going to have 16 integrate from negative half pi to half pi. And we are going to have 1 minus cosine 4 theta d theta. And with this, we could start combining some of the parts. Alright, so let's say for your first term, you're going to see a 48 over 3, which is just 16, which will, so 16, it will give you 80 pi. So these combine to be 80 pi, while this will just give you a 16 pi. And of course for this term behind, since it is a sine 4 theta, that when you substitute in half pi and negative half pi, that will just be 0. Right, so at last, the answer you get is 96 pi. Right, now this 96 pi is the volume bounded by the paraboloid, the cylinder, and the plane. Right, but is this the only way you can solve it? Well, not really, since here you used integrate with respect to x first. You can also choose to integrate with respect to y first, or even z first and so on, if you know how to express them, alright? But the main things used here is just you can determine how each of these would look like. So more easily determine the boundaries, then you can start getting into the integration parts. Now while integrating, one main part we use here is a trigonometric substitution using sine. After you substitute in these values, you just keep using your double angle formula, whether it's double angle formula for sine or double angle formula for cosine. Alright, so this is pretty much it for this lesson. Alright, so I hope you understand everything so far. I'll be ending this lesson here, and thank you for your watching.